All right, electrons. I want you to know that electrons are my favorite unit. This is actually really hard to explain, so this is going to take cooperation on both of us. I'm going to do my best here to explain it through video. Sometimes it's best just to watch me in class and listen to a lecture, but here we go. So now we're going to talk about the orbital diagram rules, of which there are 3 for a high school chemistry student to know. So Aufbau's principle says that we always have to fill the lowest available energy level first before we can continue on. And we have to give every orbital an electron before we can go back and give them an electron pair. So here in my electron orbital diagram, so this is the orbital diagram for boron. Its atomic number is 5, and so it has 5 electrons. So we represent in an orbital diagram electrons by showing them in energy level space. Like this is a little old-fashioned where 1s is on the bottom, 2s is a higher energy level, 2p is even higher, right? 3s would have been up here, and we fill each shell with electrons. So if I were to put these 5 electrons in this diagram, Aufbau's principle says that I have to put them in this order. There's 1 electron, there's electron number 2, electron number 3, electron number 4, and then this is 2p, this is electron number 5. If I were going to sodium, then I would put, it would fill just like that. It would be 5, 6, 7, 8, 9, 10, 11. So Aufbau's principle says that we have to give everybody one of these electrons before we go back and give them a pair. And we have to start down here with the lowest energy level first and then go increasing energy levels. Electron configurations are just a way to represent where the electrons are in the atom. See, when you were younger, we taught you the Bohr diagrams, and that were the nucleus on the center, and then these electrons were moving 2 of them on this, and then more of them on the second, and we noted that that's wrong. Bohr was right about something. They do have energy levels, but they're not rotating in this pattern. They're rotating in a pattern a little bit more specific to that, and we use quantum numbers in order to describe where those location of those electrons are. So this larger number represents the energy level. This letter right here represents the orbital, and the little exponent up top right here represents the number of electrons. And these are 3 of the 4 quantum numbers. The 4th quantum number, we'll save that for college level chemistry. The Pauli exclusion principle and the Hund's rule are 2 more rules where we can show in our orbital diagrams. So Pauli said that when 2 electrons occupy that same orbital, one will be spinning up and the other will be spinning down. So the fact that I have 1s and I have 1 electron going this way and 1 electron going that way is the exclusion principle. And what that is just that if I have 1s, the electrons are negative, right? So they want to stay as far away from each other as possible. So they're going in like opposite directions, rotating around, staying as far away as they can from each other. So they're an opposing direction. The Hund's rule says that if multiple equal orbitals are available, then the electrons are going to fill those before pairing up. So that was our 2p example. If I'm going to put electrons into 2p, I have to give each of these orbitals an electron before I can go back and give them a pair. In other words, this is the correct 2p. And if I have 2p that looks like this, I have 1 open orbital, and that's just not the case. They get all of that real estate first, and then they go back and they get a pairing electron. So the electron configuration is something that students can memorize or we can find a pattern. I'll show you this really two ways. The first way is from the original writing of how, we wrote out each electron in its block. And then of course this way, if you ever had to memorize them, there's an easier way, the zigzag method here, to memorize them, where you number all the S's, P's, D's, F's, and then just through a zigzag method we go 1S, that one's first, 2S is next, 2P, 3S, then 3P, 4S, then 3D, 4P, 5S. So if you notice right here that the electrons are going to get 5S, for example, and then go back, and as they gain more electrons, they're going to shove them into 4D. They're going to shove them into a lower energy level before they go back and start a 6S. So let's just do some practice. What does a chemistry student have to do? They have to do electron configurations. Here I have helium. Helium is element number 2, so its electron configuration is 1s. Here I have lithium. Lithium has 3 electrons, so we're just going to go in order. 1s, that's full with 2, and 2s, 1. If I want to do the orbital diagrams, for helium, for example, then helium is going to have 1s and it's going to have 2 electrons. Lithium will have both the 1s and the 2s energy level orbitals, and I'll have 2 electrons there going in opposite direction and only 1 electron in 2s.